Here is another very interesting question on finding minimum time to do a job. So it is a pair of scuba divers wish to dive on a wreck that lies 0.4 kilometer off the shore from a point 0.8 kilometers from their present position. If they can walk carrying their gear at 5 kilometers per hour and swim at 3 kilometers per hour, what course should they follow to reach the wreck in the minimum time? Right? You'll get many of these kinds of questions, and the strategy here is very simple to follow. Here it is like this. Think about this as this is the shore along which the scuba divers are walking, right? And that is their present position, and they are at a point which is 0.8 kilometers away from this particular point. And why this particular point is important? Because right across this particular point we have a wreck which they want to reach, right? So that is kind of the situation, and we are given that. Let's read the question once again. A pair of scuba divers wish to dive on a wreck that lies 0.4 kilometer off the shore. This is the shore, off the shore, from a point which is 0.8 kilometer from their present position, right? So they are at position A, and from this point B we have a wreck which is C. So this is the situation, correct? Now distances given are kind of like this. This distance is 0.4, and this distance between A and B is 0.8. Everything is in kilometers, correct? So this is all in kilometers. So that is the distance from here to here. Now how can they reach the wreck? So one thing is they can just go straight, correct? They can straight away swim. This is one option, correct? The second option is they can actually walk and then reach. And the third option is that they walk some distance, since they are fast walkers, and then they swim across, kind of like this. So this is a third option. So let's go with the third option for the time being. That is, they walk some distance, we don't know how much. It could be 0 or it could be 0.8. They walk some distance and then they dive in. So this is a scenario. And for the time being, we'll say that some distance they walk is x. We'll use this as our reference and say this is our distance x they don't walk, and they walk a distance which is 0.8 minus x. So from here to here they walk. Let's say they walk this much of distance and then they swim across, correct? So let that be the scenario, and that means they are walking till point D, right? And then they swim across. So that is the scenario which will work. Now, if you see this distance x, which they are not walking, is how much? This could be 0 if they walk up to this point and then swim, or this could be 0.8, right? So we have a boundary condition here. So we say x is greater than equal to 0 and is less than equals to 0.8, correct? So that is the boundary condition in this particular question. Now since we want to find minimum time, what we should do is we should see distance over time. Distance over speed is time, right? So we know time equals to distance over speed. Now in this case, there will be time taken for walking and time for swimming, correct? So walking time will be distance they walk divided by their distance or their speed of walking. So which is distance they walk is 0.8 minus x over the walking speed, which is 5 kilometers per hour. And the time they take for swimming is the distance they swim. Well, in this case the hypotenuse, right? So how will you find the hypotenuse? It will be square of x plus square of 0.4 square root. So the distance here is x square plus 0.4 square. That's the distance. And time taken will be, when you divide this by 3. 3 is their swimming speed. So we get our equation that says total time taken will be walking distance plus swimming distance, and that is walking and that is swimming distance. Now to find the minimum point, let's find the critical point after getting the derivative. So we'll do derivative with respect to x of all this. The derivative of the first function is 0.8 is 0 and minus 1 is minus 1. Minus x is minus 1. So we get minus 1 over 5 here. Now this is a square root function, so derivative of this will be 1 over the square root. So first let me write down 1 over 3. Then square root function will be half times all this square root thing comes in the denominator. By now you are an expert on all this. 0.4 square, let me write this as 0.16 square root times the derivative of the numerator, which is 2x. So 2x. So that is my derivative for this, and this I can simplify a bit and write down as 1 over 5, and 2 and 2 cancel for me, so I get x on the top. Right, let me write plus here first, and then 3 times square root of x square plus 0.16, 0.16, correct? So that is my expression for dt dx. Okay, now in this case, what I'm interested in finding is when will it be 0? So let's find the critical number, right? So let's find critical number. So for critical number, what is the condition? That dt dx should be equal to 0 for critical number. So let's equate this to 0 and then try to solve this equation. So we have 0 equals to minus 1 over 5 plus x over 3 times square root of x square plus 0.16. So we'll take this term on this side and then solve for x. So what we'll do is, okay, so we have 1 over 5 equals to x over square root 3 times square root of x square plus 0.16, and then we'll cross multiply, so we get 3 times square root of x square plus 0.16 equals to 5x. And now we can square both sides, right? So let me square both sides. So we get 9 times, and the square root goes, we get x square plus 0.16 equals to 25x square. Now let me take it here for balance of solution. Okay, yes. And now, so we'll bring all the x squared terms on one side and then try to find out the answer. So it is, okay, so let me do it. So we have 9x squared, and we'll open this bracket, 9 times 0.16. So let me do 9 times 0.16 is equals to 1.44. Okay, so 9x squared plus 1.44 equals to 25x squared, right? Now this is, so 1.44 equals to 25 minus 9, which is 16x squared. Now we can square root it, right? Or what is x squared equals to? So x squared equals to 1.44 over 16, and x is equals to square root of 1.44 over 16. So which is square root of, within brackets, 1.44 divided by 16 bracket close equals to 0.3. Okay, so we can write here x equals to 0.3. So that is the distance which they don't walk, right? So 0.3 is the distance which they don't walk. Now, we have to prove that this gives you the minimum time, right? To prove it, we have got a critical point which is 0.3, x equals to, and then we have two extreme values. One is 0, the other one is 0.8. So what we need to do is we need to find time for all the three scenarios, correct? So this is your formula. So in this formula we have to plug in x equals to 0.3, x equals to 0 and x equals to 0.8 and compare the values, correct? So let's do that part. That is one way of doing it. The second way is we can use rate of change, and we can select x as more than this and less than this and see whether the distance is increasing or decreasing, right? If it is changing from decreasing to increasing, that is a minimum time. So there are two ways to do it. So we could use this equation or that. Anyway, let's follow the first equation and plug in a value 0. So that means time when x is 0. So let's do x equals to 0 and try to find what t will be at x equals to 0. So t equals to, when I put x equals to 0 here, I get, let me use calculator and then calculate the answer. 0.8 over 5 plus, I'm putting x equals to 0. So I have 0.4 in the numerator, x is 0, over 3, right? So that is the time, which is 0.8 divided by 5 equals to plus 0.3 divided by 3, which is 22 by 75 to 0.2933. So this gives me a time of 0.2933. Same calculations I will do for t when x is 0.3, right? So now I'll put 0.3 in this equation. So we get 0.8 minus 0.3 divided by 5 plus square root of 0.3 square plus 0.4 square divided by 3, right? So calculate this now. So this is equal to 0.266. And now let us calculate the value of t when the x is 0.8. In that case, we'll have 0.8 minus 0.8 over 5 plus within square root 0.8 square plus 0.4 square divided by 3. So the first term is 0 in this case, and the second term will be 0.8 square plus 0.4 square equals to, let's do square root of this, and then divided by 3. So we get 0.2981. Correct? So you can compare the timings, right? So when you compare these timings, you find that the minimum time is indeed 0.266. Therefore, they should be walking this much of distance and then getting across. So the course should be 0.8 minus x, which is 0.3. So the answer, which we can write now here, is like this. So the answer is, so they walk a distance of 0.8 minus 0.3 is 0.5 kilometers, right? And then swim across. So that is how you're going to do these kinds of questions. I hope it's absolutely clear, and you can have a lot of questions like this where there is an option. So in all these questions you have to work out all the ways and then show that this particular answer is minimum. Well, as I said, there was an alternative that you could use rate of change equation, right? And then say that the time is first decreasing and then it increases. So here it is minimum. So you could have done that also. I hope you understand the method. Thank you and all the best.